In this video, we're mostly going to be focused on looking at three different types of functions: piecewise functions, absolute value functions, composite functions. We're going to be using these functions, especially later on when we get into finding limits, finding derivatives, and finding integrals, which are the three big rocks of calculus. Okay, so first of all, let's take a look at piecewise functions. And if you had my class last year, you remember how I defined piecewise functions. I defined them as, it's the Frankenstein of functions. That's not at all what I wanted. There we go. Okay, so I defined them as the Frankenstein of functions because that's basically a piecewise, that's what a piecewise function is. It's just a bunch of functions put together. That's all it is. All right. So in this example, we have two of them. So it's the Frankenstein of functions. All right. Now looking at this, we're going to graph this piecewise function. So we're going to go ahead and sketch a pretty little graph over here. Doesn't have to be gray. And what we do is we sketch each graph and its parts. And by part, I mean we sketch this domain. We talked about domain already. That's what x can be. And so we sketch only this domain. So when x is less than or equal to 1. So I'm just going to go ahead. Here's 1. And I'm going to sketch this graph. So it would be y is equal to, I'm going to rewrite this as negative x plus 3. That means I have a slope of -1, a y-intercept of 3. So you're going to go up here, 1, 2, 3. And again, you can try this on your own before you watch this video. And then it has a slope of -1, so that means you go down 1 and over 1, and we're at our point. And I'm going to go ahead and put a solid line there since it's equal to that value. And then we go ahead and sketch that line, continuing on. All right. That's our first function. Let's go ahead and graph our second function there. And it's when x is greater than or equal to, this should be just greater than. Not both of them can be equal to. So it's just greater than. Actually, in this case, it could be because they come to the same value, but normally you wouldn't have that. So let's just do greater than. Anyway, 2x. So now remember, 2x, that's like y equals 2x. That goes through the origin. So I'm just going to put a little dot there. And then from there, it goes up to and over 1. So look at that. It goes through the same point. All right, and then up to, so 1, 2, over 1. So it's going to look something like this. And it's going to go from this point on. Okay, but with this green one, it would be open. Because if I ask, like, what is the value of 1? All right, you would use this function and you would plug 1 in there, 3 minus 1, and that would be 2. Okay, so it doesn't matter, like I said in this case, since they both meet at that same point. Okay, and so then that's sketching a piecewise function. Just be familiar with what they are and definitely familiar with how to sketch them. The next type of function we're going to take a look at is an absolute value function. Absolute value function, here is the parent function right there. Y is equal to the absolute value of x. And it's actually, an absolute value function is a piecewise function. It's a Frankenstein function. Because on one side, if you think about it, on one side you have y equals negative x, and on the other side you have y equals positive x. All right, so all absolute value functions are in fact piecewise functions. So be able to graph any and also to define them as piecewise functions. And then lastly, so we did piecewise, absolute value, and then lastly composite functions. And these are very important later on when we go and learn to find derivatives of composite functions. You have to know what they are, and most importantly, how to identify a composite function. And a composite function is composed of two functions by taking one function and putting it inside the other. So this, it can also be, this is read f of x, but it can also be like this, f little dot, open dot, g. F of g. Okay, So that means you're plugging G, whatever G is, inside of F. So in this case, it's the same thing. You're plugging G inside of F, and inside of G you have X. Okay, so we're going to take this X minus 1 and plug it in here. So what I do, okay, I rewrite that with parentheses around what the X is supposed to be, and I'm going to take all of G of X and put it in there. Okay, now when I simplify this, X minus 1 plus 1, I get just X. Go ahead and try the rest of these on your own and come back to the video, see how you did. And on this one now, I'm plugging f of x inside g, so I'm going to go ahead and rewrite your g of x function, so that's x minus 1. And inside my parentheses, which is x, I'm going to plug my f of x, which is x plus 1. When I do that, x plus 1 minus 1 is, again, just x. Now this is a little different because now you're taking 0, plugging it inside of g. So a couple of different ways you could do this is just go ahead and find g of 0. Okay, that's 0 minus 1, and g of 0 is negative 1. Now this becomes f of negative 1, so we're going to plug negative 1 inside of f, so that would be negative 1 plus 1, and that's how we get 0. Same thing here. Find f of 0. That's 0 plus 1. That gives us 1. Go ahead and plug 1 inside, so then this becomes g of just 1. That becomes 1 minus 1, or 0. Alright, so here you do g of negative 2 inside of g. Okay, so let's do this in one step. So negative 2 inside of g, so it will be negative 2 minus 1. But then you're taking that and plugging it in for x, so that is your x minus 1. And then when we simplify this, negative 2 minus 1, that's negative 3 minus 1, that gives us negative 4. Right? And then on this last one, you're plugging x inside of f of x, so it would be like taking your x plus 1 and putting that as your x value here, that plus 1, so the x plus 1 plus 1, that gives you then x plus 2. And that's a composite function. Alright, so in this video, we looked at 3 functions: piecewise, absolute value, composite. Not only be able to identify them, but be able to graph them and to use them to answer different kinds of problems like this.